today I'm very happy to have, one of OpenSense supporters and partners here, people that are actually sponsoring us, helping us spread the mission regarding Web3 security, our friends from the Drosera network. So welcome, Boba. Welcome, Kratos. Really, really happy to have you guys on. How's it going?
Not good, man. It's not really good.
Awesome.
That might be here.
One of the most beautiful Web3 security teams going around. Can we talk a little bit? So today we are here to talk about Drosera, and we're going to do that. But before doing that, I want to know a little bit, let's maybe start with Boba, then we can move to Kratos, a little bit of what brought you guys Web3 security, what was the first step in there?
Yeah. Well, I think like my background is a bit weird. I came from military GPS weapons.
Wow.
So that's like totally different space than crypto. But the thing that brought me into crypto was because what I was doing before was so closed source, right? Like couldn't really work with anybody on any of this stuff. And to me, that feels like that's the thing that everybody I know is in software engineering. That's the thing they want to do. They want to work with other software engineers. They want to work with other people in the space and to like make new things, innovate on new technology, and share what they're doing. Because we're human beings, creative, we're innovative. We want to share what we're doing with the world. So I started to check out crypto. I jumped into the deep end doing arbitrage and MEV, and mainly in Ethereum. So that kind of gave me a background in monitoring, kind of like seeing these different events out in the world and how they're happening. And I kind of started to build up this like skill set for monitoring and making these systems. I started to make that in the Cosmos space, Polkadot, Ethereum. And I made a bunch of these internal tools, and I was like, man, making this stuff internally is brutal. There's also a lot of other people who are making this stuff, but they're either not really sharing it, able to share it, or you find it was made like a year ago, and it doesn't even work anymore. And so I was like, we need to be able to fix this. Like making this system should be really easy. It should be as easy as just deploying a smart contract. Right? So that's what kind of got me into this space initially.
So one question for you is, why was it brutal? I mean, what aspect of it was brutal? I mean, was not being able to share it, or was just hard to build overall?
It was mainly the fact that there really wasn't a community of people that you could bounce a lot of this code off of. Like there wasn't, a main community built around a standard where you can say, hey, this is how you can create a system really easily. This is how you create one of these monitoring systems really simple. And it not only does it like maybe give you alerts, but it actually takes actions on chain. There really isn't anything like that is really reliable and a really easy standard to build around. And I was like, we have to have something like that in the space. And most people we talk to, when we kind of tell them about Drosera, they're like, why doesn't this exist already? Like, it's really obvious that something like this should already be here. And so I think that's resonated with quite a few people as we started to build this. It's not even really just the building part either. Like making the internal systems isn't that bad. Managing them is the hard part.
I understand.
Actually, because when you're a developer and you're making a protocol, that should be the thing you're focusing on.
Mm-hmm.
And when now you need to spend like a lot of energy on hosting all of this infrastructure, making sure that it has good uptime, making sure that you're upgrading it so that, it doesn't eventually like break and you have to change all the dependencies. It's like a whole job, right? And we're just trying to make that easier.
That's really cool. What about Kratos? Kratos, bro, I heard you're the wallet master, been working on the Harbor wallet in the past, so I was quite excited about that. So can you tell a little bit about your story, bro?
Of course, yes. It's not as cool as like GPS military grade weapons.
It's super cool too.
Well, I do have a background in computer engineering. Boba and I both went to the University of Iowa together. We've done various projects, got into crypto basically through just like hackathons and stuff, through like arbitrage bots, some experience running some algos running some bots, and just looking for opportunities, on chain, mostly Ethereum. And then from there, that kind of got me into BitGo, doing a lot of stuff like wallet related. I was like on the research and development team, experimenting with DeFi, seeing how we can kind of bring that institutional level of like security and like wallets into like the DeFi space, And that was very fun, right? I've learned a lot at BitGo. BitGo, is a pretty big name in the space. They're like the OGs, right? And I learned a lot about security and like best practices and how to do things, in terms of like securing like institutional level type of money, right? And just kind of combining those experiences is kind of a really good fit here at Drosera, right? Where like, Boba has like the background in terms of like monitoring, the background of like security, right? So how can we like sort of bring these things together and make something that's like truly, sustainable, like a nice framework for developers to create this sort of security infrastructure and like monitoring stack. So it's a really nice fit.
I mean, that's really cool because, when we think about security today, Web3 security, nobody is really taking care of that. I mean, we have different companies like Immunify and Drosera, but everything's still being developed, everything's still being decided. And the errors can be quite mystic. It's not really like, okay, you have security, you can go through the list, but it's not really obvious. I've seen people talking about circuit trappers in the past. It looks like you guys got a whole new twist on it with Drosera. And what calls my attention regarding that, especially, is the intention aspect of the framework itself. So I don't need to have my smart contracts published. This information can be public. Actually, this information can be private, and I can have my own traps going on. Can we go a little bit? I don't know who you guys want to start talking a little bit about it, but can we go about how Drosera is helping a lot of protocols keep safe without having to spend loads of money on Immunify contests, on Drosera contests, just by using smart people and being connected with researchers that are trying to, make some money? And how can they benefit from creating traps and protecting the protocol?
Yeah, I could take a first stab at it. We're very complementary to like audits, right? Audits is kind of like this static sort of security, perspective, right? It's like before you deploy it, you have audit reviewers go through it and find any bugs before deploying it, right? And like we're like on the dynamic side, right? So it's kind of like giving researchers and auditors like the tools to not only do static but also do dynamic security as well, right? And that kind of helps these researchers sort of get their mindset around like, what does ongoing sort of monitoring security look like for this protocol, right? Like, what are the boundaries of things that we should be monitoring to actually trigger some like sort of, response to like a certain type of incident that would protect this protocol, right? Maybe they depend on protocol B, maybe they depend on protocol C, like whatever it may be, right? And that you would want to sort of look at that from an ongoing basis instead of just saying, okay, we're done with our audit. Let's just kind of check it over the fence and kind of moving on, right? It's that dynamic part that I think gives protocols, a huge sort of advantage and just ongoing security. And just today how it's done, right? You have protocols spending quite a bit of resources on just building their own sort of in-house monitoring sort of solutions, right? At BitGo, we have entire DevOps teams, managing microservices, things like Grafana, right? That like analyze logs, they analyze traces, and metrics, and they create these like SLO alerts and like sort of thing that they can kind of, get sort of propagated up to like their viewpoint of like, I'd say like Slack or Telegram or whatever. And then they sort of like see that alert and they triage over it and decide like what to do in that sort of scenario, right? And we're trying to essentially just streamline that entire process of like, what the conditions are, what that alert is. Why not just like programmatically do something about it instead of having to like triage over it essentially? So it's kind of like, it's a framework that provides like a new sort of mindset and mindshare for security.
One question regarding that is, whenever I'm setting up a trap, and let's say so one basic question that comes to everyone's mind regarding hacks and everything is, okay, someone is stealing $200 million from a contract. why don't I have some sort of variable there, some sort of circuit breaker that just say, hey, someone is transferring too much money and don't allow it, and I know it may seem a little bit obvious, but why people are not looking at that today? And regarding Drosera, if someone is making an action on the smart contract, and let's say, are you guys front running that transaction to allow it to block it? How that happen?
And so basically, what we're doing is we're creating a system that acts as like an objective node client that can take actions for you depending on what you've programmatically written in your smart contract, in your trap, right? Which is your security infrastructure. So it's looking at objective state data, and it's saying mathematically this incident absolutely occurred, so I'm going to take an action to respond to seeing that data. This allows for you to do stuff where you can have like ZKPs. You can generate zero knowledge proofs to say 100% objectively this thing did happen, so an action is needed. This takes away any like subjectivity behind these emergency systems. When you kind of have a lot of subjectivity behind your incident response system or your emergency response system, it's kind of like a trust me, bro.
Yeah.
And, you know, it's like, I mean, we just kind of have to hope that this system is doing what they say it's doing. Whereas, you know, with Drosera, it's just math, right? It's just smart contracts execution in a way that is mathematically provable and verifiable. So when we see an incident occur, then these node operators will basically work together to have this emergency action taken as fast as possible. And this is really important because it allows for us to like act within a block, right? It allows for like multi-transaction hacks to be mitigated. It allows for dependency risk to also get mitigated. So if like a bridge that you're using breaks down, you can act as soon as possible, right? You know, I think that there's definitely a lot of really important stuff going on with being able to front run exploits and being able to provide really any level of security. Like some level of security is better than no security.
Yeah.
Well, right.
Yeah.
But our approach is simply not doing it front running. It could be something we do in the future, but right now, really what we're doing is we're just trying to make a system that doesn't break composability, right, on your contracts. It's just something that is like an added layer on top of your protocol that, you know, doesn't affect how other contracts interact with your protocol. It's simply like an appendage, like a tentacle that is helping kind of, eat the bugs basically as they come up.
Very interesting. And one question, go on, Kratos, sorry.
Yeah, I was just gonna say, you know, it's kind of like when you get into like the front running scenarios, you kind of start getting into like Web 2.5 or like censorship, right? It kind of breaks the entire ethos of like, you know, crypto or like DeFi, right? Where things are like Lego blocks, you know, you can interact within your protocol that you'd want to, right? And so once you start putting systems in front of that, you're essentially just kind of getting back to like the Web 2 sort of ethos of like where you're, you know, you're breaking composability, you're having some level of like censorship, right? And so we want to sort of maintain like just being true to like the actual ethos of crypto.
Really. Yeah. We want to make sure protocols have their sovereignty, right? If, you know, they can feel comfortable using Drosera because basically having Drosera being used in our protocol isn't going to like break their system, right? It's if something happens to Drosera, it's not going to make it so that their whole system doesn't work anymore, right? It's simply a support tool. It's something that is a helpful benefit, right, to the protocol, rather than being a potential double-edged sword. Right?
I think you guys put it in a very nice way regarding static versus dynamic security measures. So whenever we're talking audits, everything's so novel that we can just have a new bug on the compiler tomorrow, and then everybody's in panic. It looks like setting up Drosera gives me the possibility of having different steps and organize myself in a way that I can, maybe think on more scenarios and allow me to be a little bit more flexible. That's quite interesting. I think we need to put simply an explanation what Drosera is, and maybe we can explain as layers of security that you can integrate into your smart contracts, but those are it's not like an audit. They are pre-thought of, so I can mathematically look at the scenarios that I'm not trying to have, with people transferring too much money, invalid signatures, and so on. Can you guys give me a simple explanation so everybody gets what Drosera is?
Yeah, absolutely. So one phrase that we like to use is security infrastructure as Solidity code, right?
Wow.
So from a user's perspective, you're just making a smart contract, just like any other Solidity smart contract, except it has some unique functions in it that basically just like act as like some standard interface functions that you would see in any type of like ERC20 standard or some other standard in Ethereum. And so it's essentially like a security infrastructure standard. It's a smart contract that you can develop that can read from any data on chain. It can do analysis on any of that data that it reads. It's just like any other Solidity smart contract. But the difference here is when you deploy it off chain to the node operators of the network. And these node operators will actually run your smart contract 24/7. So every block, they'll run your contract function. So it's kind of like this constant check based off of logic that you wrote. So you are the one that kind of has control of your destiny of like, what are the conditions that I want to look for? What is all the data that I want to query? And so you could think of it as like off-chain smart contracts that when your conditions in your smart contracts are triggered, then you specify an emergency function on chain. It just means specify an address on chain and then specify a function on chain that you want the operator to call, right? And so Drosera basically facilitates this using, BLS signatures, cryptography, etc. So it's like super secure. It's set up in a way where the operators can come to consensus to take that action that you defined when this condition has been triggered, or they could also like provide like a snark proof, like a ZKP, to say mathematically no consensus is needed. I have just proven to you that this incident occurred, and then the action will be taken on chain. So hopefully that helps, and also maybe for like a good visual way to understand Drosera. Drosera is named after a carnivorous plant. And the idea is that these traps are like Venus flytraps, right?
Okay.
They are these little traps that catch bugs when you hydrate them with some token, incentivize node operators to run your trap, right? And they'll kind of keep the flies away from your protocol.
Sounds like a mix of... Go on, Kratos.
Yeah, I just wanted to add to what Bobo was saying, that like we actually gave these traps superpowers beyond what contracts can usually do nowadays, which is they have the ability to look at history. So we run these things 24/7, right? But we also keep or like save what was previously monitored before, right? So the trap has two functions. It has collect and it has should respond. This collect is meant to actually grab any relevant data on chain, and then you can sort of transform it into any structure that you'd want and output that. And then that output is saved on the operator. And so then when it calls should respond, for that block, it takes in the previously collected data that you've structured, and then you can run analysis on that history of data. So like it gives the ability to actually detect, siphons over time. You can do sort of time series analysis over this data, beyond just like looking at it like a pure snapshot, block by block basis, basically.
That's very interesting. Sounds like you guys. So when we're talking about running smart contracts on chain and not having. Did you guys modify GIF? So we have a different version of Git running private pools. That's what we have today on Drosera for the node operators.
Oh, you're saying a different version of Geth?
Yeah.
Yeah. So truly, the great part about Drosera, one of the great parts, is that these node operators aren't actually running full nodes, and
Wow.
they actually are acting more like light clients. So they're really lightweight. Like basically anybody can run an operator on your, on your Mac, on your PC, probably on like a Raspberry Pi. They're really, really lightweight. So they're essentially just it's just written in Rust, right? It's just a light client essentially written in Rust that just taking in block data and then running the contracts inside of Revum. And Revum is basically just like a Rust EVM implementation. If you're familiar with Reth is like that kind of like Rust Ethereum validator execution client, right? And so we're also using Revum, but we don't need kind of like a lot of the other bells and whistles because we're not like including transactions on chain. So we're not doing like analysis of transactions. We're looking at just all of Ethereum state. And so we can just query basically other validators, other RPCs and nodes for that state while we're running our light client. And this is really, really awesome because it means that, anybody can run one of these things. We can run multiple operators on one machine. It's very, very flexible. So we really wanted to tap into that like decentralized nature of the space by having low hardware requirements that anyone anywhere in the world can participate.
That's very cool. Go on, Kratos.
Yeah, so it's like essentially running these contracts over like a shadow fork, if you're familiar with that concept.
Yeah.
Right. It's just basically downloading like a shadow state of what's needed. And so we're actually able to essentially determine like every like account, every storage slot that's actually needed for your trap. And then we've devised a way to sort of query this information efficiently. And these operators can also run more than just one trap. They can run multiple traps, right? And so you as a developer could even run your own operator. And then once that's running, it's essentially a machine that can run multiple programs at once, right? And it can do it dynamically as well. You don't have to you don't like restart the operator. You can actually just essentially create these traps, deploy them one by one, and it's just going to pick it up and run it.
That's very interesting. So I guess the way it works is I have my smart contract as a developer, and I can create an incentivization program to have people setting up Drosera nodes. And then one question that I have is, I'm paying per trap or I'm paying for the overall trap system? So it depends on how critical is that invariant, how I'm paying that. I'm paying per trap or I'm paying everything?
Yeah, you're paying per trap, essentially.
Okay. So the more important traps, I can put more money in the more important traps. That's it, right?
Right. The idea here is that, people Drosera basically acts as like a marketplace for your traps, right? You deploy a trap, you incentivize it by, putting Dro on it. And then you say, all right, any operator willing to come in and receive some token for running my trap. What we kind of envision is that there's enough traps basically out there in the ecosystem that an operator can opt into like multiple traps and be able to be profitable and just off of like a really small amount of money being streamed to them from each trap. So it kind of means like the more traps there are, technically the cheaper it should be to actually monetize or incentivize a trap over time, because an operator, running 5 traps is probably already like fairly profitable. They see a new trap and it's, it puts, out of who knows, maybe like $1,000 worth of value on it. They're like, yeah, I'll definitely jump onto that trap and run it for a couple of months. And this should allow for us to scale the system like really efficiently.
That's very smart and that's very novel too. How you guys come up with that? Like that, it's very different. You guys drunk or something, like having a beer on a Sunday, like, hey, I have this idea. Let's do this. This is very like
we
seems
spent
very
quite a
profitable.
lot of time. We spent quite a lot of time on trying to figure out the reward mechanism, because there's lots of mechanisms out there where, maybe it's like a Dutch auction where somebody has like an ask and a bid, and I say, oh, I'll, bid, this amount of ETH to perform this action. But with Drosera, it's like a bit different because operators are running 24/7, right? You're kind of, when you opt into a trap, you're kind of like, I'm just going to be running it. And if anything ever happens, I'm going to try to come to consensus or create a ZKP and push it on chain, right? And so this means that you need to have some trickle, right, of token, of incentive while you're running. And we call these things hydration streams. A hydration stream is you deposit token on the trap itself, and then it will stream out to the operators that are running this trap. And so this provides kind of like a consistent incentive for the running. And then there's also kind of like a bonus pool of rewards that is given to the operator that actually takes action first, with the consensus of all the other operators. So it took us quite some time to identify how to do the system, but I think like the end result is something we think will be very attractive for operators and developers.
Yeah, I have to like truly understand like what we were doing, like the base level, right? It's very comparable to like, some like cloud like provider sort of platform, like AWS or like Railway or whatever. You're paying sort of monthly for like compute essentially, right? And we wanted to kind of follow that model, but not do it in like a Web2 way. So we wanted to maintain to like a Web3 sort of ethos, but also kind of follow in the same sort of model of like cloud providers. And so we kind of landed on this, on this structure.
That's very interesting. And one question that I have for you guys regarding running nodes versus building traps. For the person that is building the trap itself, I guess there's a model of profitability, and for the person running the nodes, there's another model. How does those differentiate?
I was just going to say that the model for like a trap creator and like any kind of like profitability there, I would say that I see that more on the side of like you're a researcher, you're an auditor, you're somebody who is already like providing a service to review somebody's protocol. And so as a part of doing that work, like, saying, hey, I have these findings or these like bugs, or there's like this risk that you should think about this protocol. You could also say, hey, I have this contract I wrote, this Drosera trap, and it does analysis over like treasury, your multi-sig, some like kind of magic coefficients maybe that you have in your protocol, and it takes this pause action if there's some invariant that is seen there, and you can provide that and say, hey, here's this trap, you can use this, and you can provide that kind of as like a service, right? To say like, hey, I'm supporting your protocol by creating this trap. It kind of adds like another kind of skill set for auditors to kind of, and security researchers.
I do get it. I do get it. Like outside experience. I mean, if you manage to build really good traps, you definitely have something there in your mind. So regarding variants and how systems should behave, that is very valuable. And you can also build really good traps and run them yourself. So I mean, this is it makes a lot of sense on that aspect. So to have Drosera working on my smart contract, do I need to import anything? There's any sort of in-code actions that I need to take, or I can just do it completely separated from my code?
Yeah, it's very flexible. I think Kratos, you can take this.
Yeah. So kind of going back to what Bolo was saying about, security infrastructure as Solidity code, right? when designing or thinking about the developer experience around, deploying perhaps creating things. We sort of follow the same ethos as like some of the Web 2 companies out there in terms of like tooling, right? Like you look at Terraform, look at Kubernetes, right? It's all in this very declarative sort of manner. You have resources and context files, right? And so like you sort of like what you see is like what you get. And you use the CLI tool to sort of deploy these resources, right? And you can run that tool over and over again, like on the same config, and that's what's going to change. But like once you change one little aspect of the resources, it's going to detect that change and then go and deploy it, right? And kind of give you what you defined. And we follow that same sort of principle as when we're designing our CLI tool. And so all you have to do is just basically download our CLI tool, go to our Chat Foundry template, and essentially just initialize that template and use our CLI tool to deploy the trap, right? All it is one single command, it's Drosera apply. Essentially, we use a tonal file that basically you can specify, this is the path to like my Solidity contract. Like here's the bytecode, here's the API. You can even add some like parameters in there to configure like on the trap, and then you use from that Drosera apply command, and then goes and deploys it this piece on chain. Then it goes and takes your off chain portion of your trap, deploys it to the operator set as well. And then like you're basically done from there, and then operators will pick it up and start executing it. So it kind of gives you that Terraform-esque feel of like infrastructure when you're deploying things.
And there's another question there regarding permissions. So we're talking about dealing with unexpected scenarios when it comes to traps, right? How does the permissioning system works? How does the trap manager or the node operator is able to stop a transaction, or how that permission is given to him?
Yeah, I mean, so basically, in terms of integration with your protocol, it's very straightforward. It's really flexible. So you if you want to say, this emergency action that lives on my protocol, it takes like a pause function. This is the thing that I want to have this thing called, right? If something today has seen, all you have to do is you can add like a little accessor, a little require statement.
Okay.
That pause function that just says the trap config that I deployed is one of the people that can call this, and that trap config will only call that pause function if there's either a majority consensus between node operators or a ZKP was pushed on chain. So in terms of integration into your protocol, it could be like one line, right? At a minimum, it could just be a single require statement. But it also doesn't need to even be that, right? Because you can specify any smart contract in any smart contract function, you can kind of create a whole nother contract that maybe takes some action. Or you could just use it for alerting and not specify a contract to call, right? It's super flexible, which means people can experiment with this, and they don't feel like they need to change their whole entire protocol just to use Drosera, right? At a maximum, they just need to add like a single line to allow the trap config on chain to a emergency function.
That's very cool. So we're talking about a little bit of whitelisting plus ZKP. So what I mean whitelisting is more like, okay, there's this consensus between the node operators. So maybe there's a multi-sig or some sort of account abstraction in there. I mean, guys, sounds to me like you guys are perfect for the current flow of Web3 security, because what we have today, the way I see it, we have private auditing firms. Usually they can be good, like OpenZeppelin and Sparebit, but most of the time they lack some sort of aspect. We have the stronger competitor, which is called Arena, Sherlock, which, you bring a lot of low-level talent and some good-level talent. Then you have, a long-fought scheme like Immunify, where you can pay for have constant audits on live contracts. But Drosera really brings something novel, which is the flexibility of choosing in the marketplace what I'm looking at, what is the most important thing. And the more I incentivize the node operators, the more they'll be aware of that. So it seems like you guys are bringing a really important part of the infrastructure here, which is let's keep on dynamically changing the way we look at security, because things can change from one day to the other. So definitely congratulations on the tool. Did you guys did a raise? How does the company? Are you guys doing a token? What is the scheme? Can I invest in the project? Where's the scheme for the futures?
Yeah, I mean, there's been a lot of updates over the past couple of months. We've been very busy. We've got a test net that's been like underway with like a small group for like about like a month and a half. And we're trying to get more people into the test net right now. We're basically kind of like sending out a little sign up form for any security researchers, like auditors, just devs in general, protocols to come and play with the technology on Wesky. And so, yeah, we're just trying to get people in so that we can eventually do some try trap me challenges. It's kind of like try hack me, but they're like these little challenges where we basically make a little protocol and we have everybody try to set up a trap to do some analysis on the protocol. And then we're basically going to exploit it at some random period of time.
Really cool.
And whoever can see this exploit occur the fastest will be kind of the winner of the challenge. And then any like subsequent other people that were able to see the exploit will also kind of get the ability to be like labeled as participants. We're going to have like an NFT kind of certified trappers for participating in these challenges, just as a way to kind of get people in the door. And so, yeah, the idea here is that, you know, this is like an incentivized test net. So we want people to come in and play with the technology. We want to be able to give something back to the community as well for joining in and giving us one back.
Just one question regarding being the fastest person to see the hack. We're talking about being able to recognize the trap or being able to write the most optimal trap.
Both. Right now, the way that it's set up, it's whoever can have their action actually take place first.
Awesome.
So, you know, you can, if you boost your trap with some ETH, then, you know, it should be picked up first. And then the idea here is that we basically just have people create traps that submits like an answer that says like maybe what was the change in liquidity or who was the new owner when the multi-sig shouldn't have changed. We actually just saw a hack that happened a day ago.
Yeah. Yeah. Radiant Finance, right? Yeah.
And so we have an example of something like that where you can see a multi-sig owner change when it shouldn't have changed. And yeah, the idea is just to be like if you make the trap and you're not the first person to have your trap trigger, that's fine. As long as it triggers like within a time window, basically, then you're kind of like a successful participant. But yeah, that's something we're going to kick off the next couple of weeks. I want to get as many people in. Yeah,
I'm gonna get running like all these nodes. I'm gonna be a big node operator, bro. I'm profiting from this system. You know, I'm profiting from you. You better believe me. Guys, I mean, this is amazing. The form for the testnet will be here. One thing I will do a after session on this video to talk a little bit about how to run operator nodes so everybody can take part and profit from running different traps. I think that's very important. Please send me the link for the form for the testnet so I can send to the researchers. Thank you so much. I mean, this is very insightful. Do you guys have any closing thoughts, any message you guys want to leave the researchers here?
I have great eyes. That's for sure. Yeah. So, I would say like, you know, Drosera is like this kind of very new thing that people haven't seen before. And so there's lots of complications of like trying to understand some of this kind of complex functionality, but we have like dev docs, we have tons of resources, we have videos coming out. There's lots for people to kind of like consume and understand what Drosera is. But the one thing I want to hit home is that the biggest differentiator with us making Drosera is that it's supposed to be something like community focused. Like we want to kind of bring together all of the security researcher community all of these kind of like devs that are working on these monitoring systems, bring them together to say, look at this standard and use this as a playground for everybody to like create code and share code, do open source collaboration with your kind of fellow open source community members, and just like make cool shit. Right.
That's pretty
That's
cool.
what we're all about.
Yeah, absolutely. Like, security researchers, come test your might, basically. You guys are like perfect for this sort of role. You guys look at smart contract code all day. You guys find the bugs. You guys know the bugs. Like, take that like experience and expertise, place it on a new framework, place it on Drosera, and like, just create crazy value basically for protocols.
I can see that's going to get really big in the future. I think I'm going to try my best to spread the word and make people understand, because it's very novel as a concept. I know that Kratos was talking about in the Web2 infrastructure. We have AWS, we have a lot of different systems going on today, but it took a lot of time for people to understand those and to use them effectively. But thankfully, Web3 is made of younger, technically most savvy dudes. So I'm going to try my best to spread it. It was really, really insightful. I'm going to do a section after this video on running a node and looking at the traps, looking at the trap marketplace, how you can set up everything. I want to thank you guys so much for supporting us, and I'll be sure to run those nodes, bro. I'm looking into these traps, and I'm going to make everybody understand they can make money just by running smart code. So thank you guys so much for coming over, okay?
Yeah, man. Thanks for having us.
See you guys. Bye-bye.
Yeah, man.
Have a good one.